A billion-year-old uninvited guest meteorite fragment crashes into Georgia home, predating Earth's existence. Imagine waking up to find a hole in your roof and a crater on your floor, courtesy of a visitor from the depths of space, one that's been traveling for billions of years, long before our planet even existed. This is precisely what happened to a Georgia homeowner on June 26, 2025, when a meteorite fragment burst through their roof, leaving a trail of astonishment and scientific curiosity in its wake. The celestial intruder's journey. Captured by dashcam footage over Lexington, South Carolina, the meteorite's fiery descent into the Earth's atmosphere marked the end of an unimaginably long journey. According to University of Georgia geologist Scott Harris, this ancient relic originated from the asteroid belt between Mars and Jupiter, a region teeming with remnants from the solar system's formation. A hole in the roof, a window to the past. Upon examining the impact site, Harris discovered a remarkably clean hole through the roof, an air duct, insulation, and finally, the ceiling, culminating in a small crater on the floor, about the size of a large cherry tomato. The force of impact was so intense that part of the meteorite was pulverized, akin to being hit with a sledgehammer. Notably, this ancient fragment briefly broke the sound barrier as it entered our atmosphere, unraveling the secrets of the solar system's dawn. Dating back approximately 4.56 billion years, these meteorites are among the oldest objects in our solar system, predating the Earth's estimated 4.54 billion year age. By studying such fragments, scientists gain invaluable insights into the processes that shaped our rocky planets during the solar system's early days. The bigger picture, assessing the risk of celestial collisions. While the small fragment posed no threat, understanding its dynamics is crucial for assessing the risks associated with larger, potentially catastrophic meteorites. The ultimate goal, as Harris explains, is to develop strategies for avoiding collisions, such as the kinetic impactor technique demonstrated by the DART mission, which could nudge an asteroid off its collision course with Earth. Given enough advance warning, but here's where it gets controversial. Should the focus be solely on defensive measures, or is it time to explore more proactive approaches to asteroid threats? Could the study of ancient meteorites like this one hold the key to unlocking new technologies for asteroid deflection or even exploitation? And this is the part most people miss. The study of meteorites isn't just about understanding the past. It's about securing our future in a universe full of unpredictable celestial bodies. So the question remains, how should humanity approach the challenge of asteroid threats in the coming decades? We want to hear from you. Do you think asteroid deflection technologies should be a global priority? Could the study of ancient meteorites lead to breakthroughs in space exploration or resource utilization? Share your thoughts on how humanity should navigate the risks and opportunities presented by near-Earth asteroids.